Hello, I am Baudouin de Charlier, and I'm going to present you our paper about simplification of expressions. This is a joint work with mettons Atildeu. Here is the plan of the presentation. In fact, the idea of our method is to in order to simplify an expression, we will compute the set of all expressions that are equal to that expression, to that particular expression, and then we will pick the simplest one in this set. And to do that, we propose a new data structure, which is called a set of structure, namely that allows you to represent a very large sets of expression or terms, and often infinite sets. And I will first give you an idea of this new data structure on a simple example to show how it can be used to solve equations between terms. Then I will use it to compute a large set of terms that are equivalent according to a formal theory defined by axioms. The difference with equations is that in axioms we have variables, and I will use it to simplify Boolean expressions with only 3 variables, because it is a somewhat small theory. And I'll show you how it works. My presentation will be essentially a machine demonstration. So, since this approach works only for small theory, we have designed another algorithm that works for more complicated situations. And this is the goal-oriented algorithm, and I'll show you how it works on more complicated expression to be simplified. Then I will relate our work mainly to congruent closure algorithms, and I will end the presentation by a discussion of possible future work. Okay. So I start. So here is the file with a quite simple equation between two terms. A is a constant, and f is a function symbol. Okay. This equations tells us that any application of f to any number of application f to a, f of a, and so on, is equal to a. And this will be computed thanks to by our method very easily, as I will show you. So I will execute an algorithm which is called bottom up on this file of axioms. Okay, and that's not correct. In fact, okay, this is correct. So, in fact, the algorithm has created one set of structure. In fact, the algorithm, by analyzing the equation, has created two structures, f of 1, 1, a, 1. A structure is an object composed of two parts. The first part is the key, and the second part is the identifier of the set of structures to which the structure belongs. Here we have just one set of structure, and its identifier is 1. Okay? And in fact, the structure described represent a set of terms. This structure represents just the constant A, and it says that it belongs to the set 1. But this structure says that any terms represented by the set 1 and to which I have applied f also belongs to the set 1. So f of a belongs to set 1, f of a belongs to the set 1, and so on. So any application of f to a belongs to the set 1. And I can use it to simplify expressions involving a number of times the f symbol. It's okay. And we can see that the expression simplifies to A because it is the simple expression corresponding to this set of structures.